Okay, thank you, and good afternoon, distinguished participants, guests, ladies and gentlemen. Well, my presentation is entitled Applications of Modern Remote Sensing Technologies for Environmental Studies in Mongolia. And within the framework of this topic, at the beginning, I'll give you a brief introduction, and then I will talk about three different case studies, namely pasture land degradation study using multitemporal remote sensing, optical remote sensing, and forest resources mapping using interferometric synthetic aperture radar, or abbreviated as InSAR technique, and land cover mapping using hyperspectral remote sensing, and then I will conclude my presentation by a brief summary. Well, for environmental studies, the spatial information can play an important role, and such information in general can be collected from a number of sources, such as field surveys, planning maps, topographic maps, digital cartography, thematic maps, remote sensing, GIS, and GPS. And of these, only remote sensing can provide real-time contiguous or aerial information. In general, remote sensing can be defined as the art, science, and technology of obtaining information about the Earth's objects without any physical contact. And Mongolia has a long history with remote sensing applications, and the first official use of remote sensing application was registered in December of 1970. Here you can see the cloud image acquired from an American satellite in December of 1970 by meteorological specialists of Mongolia. And in the current study, in general, we wanted to demonstrate different applications of modern spatial technologies based on optical, radar, and hyperspectral remote sensing for environmental studies in Mongolia. And for this purpose, we have used multi-source satellite images with different spectral and spatial resolutions. Now let me talk about my first case study, entitled Pasture Land Degradation Study using Multitemporal Optical Images. And as data sources, we have used multitemporal satellite images mainly acquired from Landsat in 1987, 2001, and 2014. And in addition, we had topographic map of the study area, as well as pasture map of a scale of 1 to 200,000, and some other GPS measurements and ground truth datasets. Here you can see Landsat images acquired in 1987, 2001, and 2014. Well, the test site is located in the northern regions of Arhanga province, central Mongolia. Well, actually, this area represents 3 zones located in the northern part of the province. And as the advanced classification method, we used refined minimum distance classification, and unlike the traditional technique, the constructed classification algorithm uses spatial properties of the available land cover classes. Here you can see the results of the classification from the refined minimum distance classification. This is the result of 1987 image, and this is the classification result of 2001 image, and this is the classification result of 2014 image. Well, actually, we have classified land cover types into pasture land, degraded pasture land, forest, meadow vegetation, and water classes. And here you can see the distribution of those classified land cover types. If we look at the total areas belonging to the selected pasture classes, in 1987, pasture land occupied around 387,600 hectares of land, while degraded pasture land occupied 85,300 hectares. And meanwhile, in 2001, the pasture land had been degraded into 381,176 hectares, while degraded pasture land occupied 183,756 hectares. And if you look at the areas of the pasture land and degraded pasture land in 2014, the pasture land occupies 275,600 hectares. Meanwhile, degraded pasture land occupied 190,000 hectares. As you could see, since 1987, the degraded pasture land had been increased even more than double. Now let me talk about my second case study entitled Forest Resources Mapping Using Interferometric SAW. And in the current study, we have used ALOS PALSAR L-band HH polarization images acquired in August of 2007 and in July of 2009. And we combined these InSAR datasets with optical satellite image acquired from Landsat. This is the test area. Well, this is the famous Hovsgol Lake located in northern part of the Mongolian territory. And here you can see different land cover types as deciduous forest, coniferous forest, light soil, dark soil, and the Hovsgol Lake itself. Here you can see the L-band images of taken from ALOS PALSAR. This is the image acquired in 2007, and this is the image acquired in 2008. Well, here you can see the coherence image calculated from these interferometric datasets, and if one is familiar with the interferometric coherence products, in general, coherence is a very good indicator of forest biomass or stem volume, and combining with other intensity or amplitude images, we can produce a very high quality forest biomass map as well as forest taxonomy map. Here you can see the color image created by combination of these two intensity and coherence images. And as the advanced mapping method, we have constructed refined maximum likelihood classification technique, and unlike the standard method, this constructed algorithm uses spatial and spectral thresholds of the available land cover classes. Here you can see the results of the forest cover mapping using InSAR and multisource images. Multisource images, we mean the combined application of ALOS PALSAR products and Landsat visible and near-infrared bands. Well, if we look at the result of the InSAR data sets, there is a high overlap between different classes, and if you look at the results of the multi-source images, the overlapping classes or the classification accuracies have been greatly improved compared to the single use of InSAR datasets. Now let me talk about my last case study entitled Land Cover Mapping Using Hyperspectral Remote Sensing. And in this study, we wanted to demonstrate how hyperspectral datasets can be used for land cover mapping in Mongolia. Well, unlike the traditional optical remote sensing, hyperspectral datasets in general include hundreds of bands, and that's why it's possible to observe spectral traces of different land cover classes which have some overlapping properties. Okay, we'll talk about these issues later on. And as data sources, we had Hyperon images of Ulaanbaatar city acquired in August of 2002. And Hyperon is a hyperspectral sensor launched by NASA in 2000. And it acquires 242 spectral band images within the range of 0.2 micrometers and 2.5 micrometers. That means this range covers the visible, near-infrared, and middle-infrared portions of the electromagnetic spectrum with the interval of 10 nanometer. And here you can see the Hyperon image created by the use of visible, near-infrared, and middle-infrared bands of the Hyperon. And this is the southern part of Ulaanbaatar city, where we have, well, usually in Mongolia we call it Ulturing or just industrial area. And this is the area located where we have clean water wells, and this is the Tall River. Well, actually we have green vegetation and bush and young forest along the Tall River, and this is the northern part of Bogtan Mountain. As I told you before, using hyperspectral images, we can look or trace the spectral properties of the land cover classes, and if we compare hyperspectral curves with the curves of the Landsat images, in the Landsat images we can see the averaged spectral reflectances. Meanwhile, in the hyperspectral images we can see or look at the detailed description of the spectral curves, and that's why it's very useful to distinguish between the overlapping spectral classes. Well, in the current study, we classified two features obtained by spectral knowledge and principal component analysis, and we used maximum likelihood classification and spectral angle mapper. And if you look at the results of the classification, we can surely say that the traditional methods still perform very well if we select the correct feature bands from hyperspectral data sets. Well, these are the results, the comparison of the results of the hyperspectral and optical images, and this is the result of the classification obtained by the Hyperon image, and this is the result of the classification obtained from Landsat images. If you look at these two results, we can see that the performance of the hyperspectral data sets is much more better than the performance of the traditional optical images. And in conclusions, I would like to say that the overall study indicated that modern spatial techniques and technologies based on the remote sensing could successfully be used for different environmental studies in Mongolia, which has a very large area in comparison with its just over 3 million people. Okay, thank you very much for the attention.
Thank you. Thank you very much.
Yeah, thank you.